Well, hello everybody, it's Dr. B. I'm so glad that you joined me today. Today we're going to be talking about learning through problem solving. And all of you are mathematicians, so I'm going to give you some problems that you're going to work through, and then I'm going to show you one way that you can solve those problems. I would like you to come up with at least 2 to 3 strategies for solving every problem that we're going to encounter today. I'm just going to give you one strategy. You need to have at least 2 or 3 more in your back pocket, so when you face these problems in the future, mathematicians, you will know exactly how to solve them. All right, let's go ahead and take a look at the problem-solving strategies, or steps in the problem-solving process. The first step is to read the problem carefully. So we're going to make sure that we read each and every problem as carefully as we can to find out what the problem is asking. Second, we're going to choose a strategy. The strategies can range from all sorts of things. You may decide to use a logical table. You may decide to guess and check, draw the problem, act it out. There are all sorts of strategies that you can use. So choose one that works for you. Remember, you want at least 2 to 3 different strategies for solving the problem. If you solve it one way, check it with another strategy and see if the answer is correct. Next, you solve the problem, working out each step, and finally checking the solution. Going back and using another strategy to check to see if the answer that you provided is correct. These are the steps of the problem-solving process, and we're going to use them as we move through these problems. The first problem that I would like you to take a look at is called Lollipop Logic. So let's begin with the first step of the problem-solving process, mathematicians. Let's read the problem. Here it is. There were 8 bags of lollipops on the table. Brian, Carrie, Maddie, and Shane each chose 2 bags. Maddie picked a bag of red lollipops and a bag of yellow. Shane picked the 2 colors that Maddie had not picked. The colors that Carrie picked have 6 letters in their names. Brian took the 2 bags left. How many lollipops did each child pick? All right, mathematicians, let's go through the problem-solving steps to read, choose a strategy, solve the problem, and then check your solution. Go ahead and press pause now. Work through this problem using a solution of your choice. Check it using a different solution, and then when you come back, I'll show you how I work the problem. Well, welcome back, mathematicians. Let's take a look. This is just one strategy of many that you can use, and this is a logic matrix that I'm using here. And when I use the logic matrix, I use I use X when I am saying, no, this is not true for this person. So X equals no, and O equals yes. So I'll just go ahead and put O up here, just so you know. O, in this case, equals yes. So I'm going to type in yes after the O. All right, so this is how I work out this problem, mathematicians. I'm going to go ahead and begin by reading it. There are 8 bags of lollipops on the table. Brian, Carrie, Maddie, and Shane each chose 2 bags. And the final question is, how many lollipops did each child pick? So I have the names along the right-hand side of the matrix, Brian, Carrie, Maddie, and Shane, and then I have the options of colors that they could choose. And I found these from the top of the problem up here. They could choose green, red, purple, or yellow. So I'm going to read through these and we'll see how many lollipops each child picks. Maddie picked a bag of red lollipops and a bag of yellow lollipops. So I know that Maddie chose red and yellow. So I'm going to go down to Maddie, and I'm going to give her a circle on red and a circle on yellow, because that was, in my mind, that means yes. And I'm going to go ahead and mark no for green, and I'm going to mark no for purple, and give those an X. The next clue, Shane picked the 2 colors that Maddie did not pick. So if Maddie chose red and yellow, I know that Shane chose green and purple. So I'm going to go ahead and give a yes to green and purple, and then I'm going to go ahead and mark an X, because I know Shane did not choose red, And I know Shane did not choose yellow. So I go ahead and go across the entire matrix and mark those out so I know and can follow the problem. The next one, the colors that Carrie picked have 6 letters in their name. Well, I know the only 2 colors that have 6 letters in their name are purple and yellow. So Carrie must have picked, that's right, purple and yellow. So I go down to Carrie and I give Carrie an O for purple and an O for yellow. And I know that Carrie did not pick green, and I know that Carrie did not pick red. So this is giving me some good information. Remember, each child picked 2 bags. So I see here the 2 bags of purple have already been chosen, and the 2 bags of yellow have already been chosen. So Brian is definitely not going to pick purple because that one has been chosen, and Brian's also not going to pick yellow. So that is going to tell me the 2 bags that are left have got to be green and red. And those are the 2 colors that Brian chose. Brian chose green and Brian chose red. So I'm going to go ahead and give Brian circles for an O in both green and red. Now, I am not finished, mathematicians. I need to go back and look at the problem. It says, how many lollipops did each child pick? So I need to go up to the top and I need to say, okay, well, let's figure out how many lollipops each child picked. Now, if we know Brian chose green and red, green has 1 bag and red 1 lollipop, and red has 3 lollipops. So Brian chose a total of, that's right, 4 lollipops. Carrie chose purple. So purple has 4 lollipops, and Carrie also chose yellow. Yellow has 2 lollipops. 4 plus 2 is? You got it, 6 lollipops for Carrie. And then I go down to Maddie. Maddie chose red, which was 3 lollipops. And Maddie also chose yellow, and yellow is 2 lollipops. So 3 plus 2 is? That's right, 3 plus 2 is 5, so Maddie had 5 lollipops. And then Shane chose green and purple. Green has 1 lollipop, and purple has 4 lollipops, for a total of 5 lollipops. So now I have the total number of lollipops that each child picked. Hopefully you came up with at least 2 or 3 different ways that you could solve this problem. Give yourself a pat on the back. Nice work, mathematicians. Let's go ahead and take a look at the next problem. The next problem is a clown problem. So the first step in the problem-solving process is to go back and read the problem. Bobby, Dan, Jess, Nick, and Tammy are wearing different clown costumes. Tammy and Dan have circles on their costumes. Jess and Dan have triangles on their costumes. Nick and Tammy have squares on their costumes. And Bobby and Nick have rectangles on their costumes. Which child is wearing which costume? Go ahead and choose 2 or 3 strategies that you're going to work on. Decide on your first one. Go ahead and work through this problem, solving it, and then check it with a different strategy and see how you did. When we come back, I'll show you how I solved the clown problem. Well, welcome back, mathematicians. Here's the clown problem in front of us, and I did it maybe a little bit differently than you. Let's take a look. I looked at all of the different clowns that we have across the top, and they each have shapes on their costumes. So I read through the clues one more time. Tammy and Dan have circles on their costume. There's no circles on the first clown, no circles on the second clown. Ah, there are circles on the third clown. So I'm going to put a T for Tammy and a D for Dan, because it could be Tammy or it could be Dan on this costume. I don't know yet. The fourth one could also be Tammy or Dan, because the fourth one also has circles on the costume. And the last one does not. The next clue, Jess and Dan have triangles on their costume. Ooh, Dan. They've told me a couple things about Dan already. So now I know that Dan has circles and triangles. So I look at all of the costumes. The only one that has circles and triangles is the third one. So I know that the third one is Dan. Jess also has triangles on her costume. So I'm going to look, and I see here that Jess is the only option for the second clown because Jess has triangles on her costume, and there are no other clowns that have triangles on their costume. So I'm going to go ahead and make clown number 2, Jess. Nick and Tammy have squares on their costume. Okay, Nick and Tammy have squares on their costume. So I'm going to go back, and I'm going to actually, oops, this is a Tammy. She's definitely not this one. So because we know that that one's Dan. And we know that this one could be Dan, number 4, but Dan already had the costume. So I'm going to go ahead and X this out. So it says here that Nick and Tammy have squares on their costume. I'm going to look. This one could be Tammy, the first one, but it also said earlier that Tammy has circles, and that one doesn't have circles. So I'm going to look here, definitely squares and circles. So this fourth one could be Tammy. And also, let's see, Tammy has, what on her costume? She also has circles. Clown number 5 does not have circles. So clown number 4 must be Tammy. So I'm going to put a T above clown number 4. Now I'm going to look at the second one, Nick. We don't know who Nick is yet. Nick has squares on his costume. So clown number 1 could be Nick, because clown number 1 has squares on the costume. And clown number 5 could also be Nick. It looks like those might be squares that are kind of sideways. So I'm going to put Nick as an option for clown number 1 and clown number 5. Here it says Bobby and Nick have rectangles on their costume. So I know that Bobby and Nick have rectangles on their costume, but Bobby doesn't have squares. This one has rectangles and squares. So this one, number 5, has got to be Nick, and number 1 has got to be Bobby. So I went through the problem-solving process, mathematicians, but I didn't do step number 4, which is check. So I need to go back and read these again to see if it's correct. Tammy and Dan have circles on their costume. Tammy's costume, yes, there's circles on it, so that's a check. And Dan's costume has circles on it, so that's a check, correct. Jess and Dan have triangles on their costume. So Jess has triangles, and Dan has triangles. So both of those are correct. Nick and Tammy have squares on their costume. Nick's costume, yep, there are squares. And Tammy's costume, yes, there are squares. Bobby and Nick have rectangles on their costume. So I'm going to go over to Bobby, and yes, there are rectangles. And I'm going to go over to Nick, and yes, there are rectangles. This problem is correct, mathematicians, because all of the clues match when I go back and check. I hope that you have 2 ways or even 3 ways that you could solve this problem. I did not use the logic matrix on this problem, the one that's over here on the right-hand side, but that's definitely another way that you could solve this clown problem. Okay, mathematicians, let's go through. The problems are going to get a bit more challenging. Here we go. The next one is the Williams family, and they are doing a photo. Let's go ahead and read it. The Williams kids are having a photo taken. The photographer has asked them to line up in order with the tallest on the left, so the tallest will be over here, and the shortest on the right. Being a mathematical family, they decided to give the photographer a puzzle. Can you solve the puzzle? So what you're going to do is you're going to put these students in order, these children, from the tallest to the shortest. Go ahead and write their names down, mathematicians. Work this problem. Hopefully you have 2 or 3 different ways that you can work this problem. I'll be back in just a few minutes and we'll take a look at it. Go ahead and press pause now. All right, welcome back, mathematicians. Let's go ahead and read through the different clues in this problem and see if we can figure it out. Now, what I have done in this problem is I've gone ahead and I'm doing some guessing and checking. That's the strategy that I'm going to use. I'm going to pull these pictures down and I'm going to put them in order based on what the story is telling me. So I'm just going to start with the first clue. Joe is taller than Lee. So I'm going to pull Joe down, and remember, I'm not going to, well, I haven't told you this, but I'm not going to put them in their seats. I'm just going to put them up here or down right above the seat so then I can guess and check and then move them when I'm completely finished. So I know that Joe is taller than Lee. So I'm going to put Joe there and I'm going to put Lee just a little bit shorter, giving some space in case I need to add somebody in between them. Lee is taller than Mike. So we know that Lee is going to be to the left of Mike. Mike is taller than Steve. So I'm going to find Steve, and Steve is shorter, so I'm going to put him towards a shorter chair. Pete is taller than Mike. Pete is taller than Mike. So I am going to put Pete on the left-hand side of Mike because he's taller. Moving these over just a smidge so we can still read the names. There we go. Pete is shorter than Lee. And I already have those two, that Pete is shorter than Lee, so that still works. Paul is directly between Julia and Eliza. So Paul, I'm going to just put him over here, is directly between Julia and Eliza. And I'm just going to pull them down. Again, it's guess and check. Eliza is shorter than Joe. So that's going to tell me that Joe's got to be over here somewhere because Eliza is shorter than Joe. Harold is directly between Joe and Kate. So Harold is directly between Joe and Kate. Again, it's just some guessing and checking here. Put Harold, and then I'm going to put Kate. So I'm going to move these over just a smidge so everybody fits in here. And bring Kate down. And then it says Eliza is taller than Paul. Ooh, Eliza's taller than Paul. So I'm going to move Eliza up, and I'm going to make her taller than Paul. But I also know that Paul is directly between Julia and Eliza, so that makes me think Julia is going to be on this side, and that's clue number 6, and Eliza is going to be on this side. Guess and check. I'm just moving them around. Kate is next to Eliza, and this is true. Kate is next to Eliza. There are 7 people between Harold and Steve. 1, 2, try this again. 1, 2, 3, 4, 5, 6, 7. That is correct. I think I have them in the right order. So I'm going to move them down into their chairs, Steve being the shortest. Pulling them all down. And then I need to go to the last step in the problem-solving process, which is what, mathematicians? Do you remember? You got it. Checking the problem. So I'm going to go ahead and get them into their chairs, how they're seated, and then I'm going to go through and make sure that this is correct by double checking. Joe is taller than Lee. So when I go down here to check, I see that Joe is taller than Lee, and that is correct. Lee is taller than Mike. Lee is taller than Mike. Correct. Mike is taller than Steve. Mike is taller than Steve. That is correct. Pete is taller than Mike. Pete is taller than Mike. Correct. Pete is shorter than Lee. Pete is shorter than Lee, and that is correct. Paul is directly between Julia and Eliza. There's Paul. directly between Julia and Eliza. That is correct. Eliza is shorter than Joe. Eliza is shorter than Joe. Correct. Harold is directly between Joe and Kate. Harold is directly between Joe and Kate. Eliza is taller than Paul. Eliza is taller than Paul. Correct. Kate is next to Eliza. Kate is next to Eliza. That is correct. And there are 7 people between Harold and Steve. 1, 2, 3, 4, 5, 6, 7. That is correct. And in this case, my strategy of guessing and checking worked very well for me. You may have done it completely different. Maybe you drew it or acted it out or created some type of logic matrix. There's all sorts of ways that you could figure this problem out. Well done, mathematicians. Remember, you want 2 or 3 other ways to solve it, just in case you have to come back. All right, you are doing a fantastic job. Let's go ahead and take a look at the next problem. This is Texas-sized jelly beans, and I have a feeling that I'm going to have a different way to solve this than you do. The way I'm looking at it is a little bit unique. Mathematicians, read through this problem, choose the strategy, solve it, check it, and then when you're done with that, unpause it, and we'll go over this together. All right, welcome back, mathematicians. Let's read this problem. The story behind the problem is there was an aunt, and she was at home, and her children, well, her nieces and nephews, thought that she might like some giant jelly beans. They got on a trip, and they brought her back some giant jelly beans from this trip. And she was trying to figure out how many jelly beans there were all together. And so there is this problem that we have in front of us, the Texas-sized jelly beans, to figure out, using the clues, how many jelly beans there are total. So let's go ahead and take a look. I'm going to use drawing it out this time. So what I'm going to do is I'm going to read through the clues, and then I'm going to draw out the different jelly beans using these clues. So let's go ahead and read them. I'm going to read them one at a time this time, and then show you the different steps. The number of red jelly beans is double the number of black jelly beans. So I'm going to go ahead and draw the black jelly beans first. There they are. And I know that the red jelly beans are twice as many as the black jelly beans. So I'm going to go ahead and get out my red marker. And I'm going to say the red jelly beans are twice as many as the black jelly beans. So I'm going to go ahead and make that about 2 times as large. And then I'm going to use some letters to represent those numbers here. So what I'm going to do is I'm going to say, okay, here's red, and I know that red, I'm going to see if I can make this a little skinnier here to show it to you. Let me see if this will work. The red, oh, it's going to have to work just fine as a marker here. The red equals 2 black. So what it's saying here is red equals 2 black, or 2 times B. And then I go down to here and I put a B. I'm going to make this a capital B, actually. It might make it a little bit easier for me. And I'm going to say B equals, I don't know how much B equals yet. So it's just some number. I'm not sure what it is. We're going to find out in just a few minutes. There's an equal number of black jelly beans and green jelly beans. So I'm going to go up and I'm going to grab my green pen and I'm going to make a representation of green jelly beans. Just like this, exactly the same size as the black. So what I'm going to say when I write this out is I'm going to say that green, which is G, equals black. G equals B. Again, using an algebraic expression or algebra to show how this problem is solved. Next, there are 2 fewer red jelly beans than yellow jelly beans. So I'm going to draw out the yellow jelly beans. Are there going to be more yellow jelly beans than red or fewer jelly beans than red? Think about that. I know that there are 2 more jelly beans than there are red. So I'm going to go over here, and I'm going to mark that so I know how many. And I'm going to say that the yellow jelly beans equal, and then I'm going to say, what does it equal? Do you remember? How do you think we would write that out? I think some of you got it. The yellow jelly beans equals R plus 2. Because there are 2 more yellow jelly beans than there are red jelly beans. There's half as many pink jelly beans as yellow jelly beans. So I'm going to go ahead and take my pink marker, and I know that there are half as many pink jelly beans as there are yellow jelly beans. So I'm just going to draw this pink out, and I'm going to make it about half the size of the yellow. And then I'm going to write myself an equation down here so I have it. And the equation for this one is what? Think about that. What would the equation be? Pink equals, and I'm just going to write 1/2 yellow. 1/2 Y. So half of Y is the answer, will give me the answer of how many pink jelly beans there are. Ah, now I have some information. I have a number here. There are 4 black jelly beans. This is really going to help me because black equals 4. So when I go over here to the jelly beans, I know that black equals 4. So I can come over to black, and I know that black equals 4. So there are 4 black jelly beans. I also know when I look here that green equals black. So if black equals 4, green must also equal 4. So I can substitute my number in there. So there are 4 green jelly beans. Red equals 2 black. So if black equals 4, red would equal 2 times 4, which also equals 8. So there are 8 red jelly beans. And then I go down to yellow, and if I know that there are 8 red jelly beans, I can just substitute an 8 in there for red, and then I can do plus 2. 8 plus 2 equals, yes, there are 10 yellow jelly beans. And if I know that there are 10 yellow jelly beans, I know that there are half as many pink jelly beans, which would equal, you got it, 5 pink jelly beans. And then the question was, how many jelly beans are there total? So I can say 8 plus 4 is 12, plus 4 is 16, plus 10 is 26, plus 5 equals 31 total jelly beans. And then I can go back and I can check my answer by saying the number of red jelly beans is double the number of black. So if I know black is 4, then red would be 8. And again, I'm just looking right here. On the left-hand side, I'm just saying 4 and 8. There is an equal number of black and green. Black is 4 and green is 4, so that's correct. There are 2 fewer red jelly beans than yellow jelly beans. So if yellow jelly beans are 10, 10 minus 2 is 8. That's correct. There are half as many pink jelly beans as yellow, and if there are 10 yellow, there are 5 pink, which is correct. And the answer for black is 4, so that's correct. Mathematicians, there are 31 jelly beans. I wonder if you did it the same way as I did, or you had a different strategy. Hopefully you have 2 or 3 different ways that you can do these problems. Thank you so much for joining me in problem solving today. Remember, there are 4 steps, problem solvers, to read the problem, choose the strategy, solve the problem, and check your answer. I hope you had fun with today's problems. And I know, mathematicians, the harder you work at these problems, the better you are going to get. If you would like some more logic problems that are like this, I will type the name of the place that you need to go into the chat area. Let me look it up quickly. It's called EduPlace, and the link is going to be here in the chat area. It's a place you can go for brain teasers, and there are all sorts of different brain teasers in the grade levels, 1st grade through 6th grade. So that's right there right now in the chat area. It's eduplace.com. There's a little bit additional information after the slash, and that will give you some more problems just like these that are at your level that you can work on your own. All right, mathematicians, you have a wonderful, wonderful day. Work hard, practice hard, and you will get better. Bye for now.